Hey, welcome to The Explainer. Today, we're jumping right into that really weird gap between just looking at something and actually seeing it. We're going to decode a single number that reveals the difference between a casual glance and deep, locked-in, focused attention.
Come on, you know that feeling, right? You're staring at a page in a book for like 5 minutes, but you haven't processed a single word. It's this bizarre truth. Just because your eyes are pointed at something, it doesn't mean your brain is switched on. And honestly, that's a huge problem that researchers, designers, and marketers have been desperate to solve for years.
For the longest time, our best tool was the good old heat map. And look, it's great for showing those hot spots on a web page where everybody's eyes land. But it's kind of like a blurry photo taken after the party's over. It can't tell you the difference between someone who is totally captivated and someone who is just mindlessly scanning the page.
And that really gets to the heart of it. These static metrics, they just tell you what was seen. It's a summary after the fact. But to really, truly understand focus, you need something dynamic. You need a measure that shows you how it was seen, moment by moment, as it's happening.
So you might think the solution came from some fancy, high-tech corporate lab, right? Well, it turns out it didn't. It actually came from a classroom, a group of kids, and a really urgent problem that sparked a genuine scientific breakthrough.
So, the story kicks off at SWPS University over in Poland. Researchers there were studying how kids learn from educational videos. They were using audio cues, to guide their gaze. But here was the problem. They could see where the kids were looking, but they had absolutely no idea if they were truly engaged. They were stuck. And like so many great inventions, what they really needed was a little bit of pressure.
And that pressure? It was a looming conference deadline. You can hear it straight from one of the inventors, Krzysztof Krejtz. He said the need to get results for a paper forced them to innovate, and innovate fast. It really is true. Necessity and a ticking clock became the mother of this invention.
So how did they do it? How did they finally crack the code? Well, it all comes down to a really simple but incredibly powerful idea. Our vision basically operates in two totally different modes.
Okay, first up, you've got ambient attention. Just think of this as your scanning mode. It's what you do when you first walk into a room or land on a new web page. Your eyes make these quick little stops. We call them short fixations. And then they make these long, sweeping jumps, which are called saccades. You're just getting the lay of the land, the general gist of what's in front of you.
But then there's focal attention. This is the focus mode. Once something actually grabs your interest, your eye movements totally change. Now you have these long, steady fixations, and you make short, precise little jumps to check out nearby details. This is your brain really digging in, actively processing what it's seeing.
But here's the really cool part. We don't just snap between these two states. It's more like a spectrum, and we're constantly shifting back and forth. The K coefficient is what captures this relationship, this dance between our long stares and our quick glances. It boils it all down into a single dynamic number that tracks our attention in real time.
Okay, so how on earth does it work? Well, to put it simply, you measure how long each fixation lasts and the length of the eye jump, the saccade, that follows it. The problem is, you can't really compare milliseconds to degrees of an angle directly. So, the key step is to standardize them both into something called z-scores. This puts them on the same scale. It's like finally being able to compare apples to apples. Then, you just calculate the difference.
And the best part, reading the result is beautifully simple. If that K value is positive, it means your fixations are long and your eye jumps are short. You're in focal attention mode. If K is negative, your fixations are short and your saccades are long. You're in that ambient scanning mode. A 0 is just a super rare transition point between the two.
Now, I've got to stop here for a second, because this is really important. When you hear K, you might think of a few other things. The Krejtz K coefficient for eye tracking is completely different from Cohen's kappa, which is a stats thing, or the K factor, which is a marketing term for virality. Let's be clear, we are only talking about the eye tracking K today.
All right, so that's the theory. It sounds cool, right? But how does this elegant little number actually perform out in the real world? Let's take a look at how it's being used to get some seriously powerful insights.
Let's kick things off with a classic, advertising. Take a Snickers ad. The goal isn't just to make you look at the logo, right? The goal is to make you actually process it, to have it sink in. But how can you prove that actually happened? Well, this is where key comes in.
And this is exactly what researchers discovered using the K coefficient. They found that as people watched the ad, their attention was mostly just ambient, kind of scanning around. But at the exact moment the brand was shown on screen, the K value spiked into positive territory. That's a clear switch to focal attention. And that, my friends, is actionable proof that the ad's main message landed.
And this isn't just for ads. This same idea is incredibly powerful for user experience and even retail. For instance, in shelf testing, the K-coefficient can pinpoint the exact moment a shopper finally recognizes the cereal box they're looking for because their attention instantly snaps into focal mode. Or for a website, if someone has a really long period of high focal attention, it might actually mean they're struggling with a confusing design, a clear signal to designers that something needs to be fixed.
And hey, remember that origin story with the kids and the videos? Well, in e-learning, the K-coefficient is a total game changer. You could have an adaptive learning system that monitors a student's K-value. If it stays focal for too long, maybe they're getting cognitively overloaded and need a break. If it's always ambient, maybe they're bored. The system could then adapt to them in real time.
Now, for the longest time, doing this kind of analysis was, reserved for PhDs in a lab. But that's changing, and it's changing fast. Today, platforms like RealEye.io can do all of this automatically, using just a standard webcam. They handle the eye tracking, they calculate the K-coefficient, and they make these deep insights accessible to just about anyone.
So where is all of this heading? What does this single number really mean for the future of how we interact with, well, pretty much everything in our digital world?
So, when you boil it all down, here's the bottom line. The K-coefficient gives us a moving picture of attention, where we used to only have a single, static snapshot. It completely changes the conversation from where did they look to how were they thinking and feeling when they looked there. It's a huge leap forward.
And get this, the innovation isn't stopping. Researchers are already looking into what they're calling a third-order coefficient. Imagine combining the K-coefficient's measure of attention with data on cognitive load, something you can actually measure through how much a person's pupils dilate. That would give us an even more complete picture of what's going on inside someone's head.
Ultimately, what the K-coefficient gives us is more than just a number. It's a whole new language, a new, much more nuanced way to describe and actually understand the incredibly complex and dynamic nature of human focus. Which really just leaves us with one final, pretty mind-blowing question to think about. From classrooms that adapt to a student's confusion, to interfaces that know exactly when you need help, what could we all design, build, and create if we had a true, real-time understanding of attention?